and welcome to this afternoon's TEL course, the Basics in Iron Fencing Care. My name is Jason Church. I'm a materials conservator at the National Center for Preservation Technology and Training, and I'm glad you joined us in today. During this course, a big part of it is participant interaction. I want to hear from you questions that you have, things that you're wondering that maybe I haven't covered at the end, or questions that come up during the broadcast today. And to do that, you need to use your push-to-talk microphone. To get the best audio, you want to hold it about 12 inches from you. Push the button very much like you would a walkie-talkie. Tell me who you are and what site you're from. Ask your question, release the button, and allow me to answer you. If we do get multiple people coming in at the same time, I'll sort of do a timeout and call on the first person I heard, answer that question, and then try to get to the next one. But it's very important to get audience participation. We really appreciate it, and make sure that you get your questions answered during the course of this class today. And also would like to do a real quick maintenance thing and tell you that this course has a participant's guide, handout, and slides, and all this is available on the NPS TEL training website, and that's available under the link for the Basics in Iron Fencing Care. So if you'd like to follow along on page 3 of that, we'll start with what are the objectives for today's class on the Basics in Iron Fencing Care. And the objectives for today are, after this workshop, or broadcast, learners will be familiar with the identification of both iron cast and wrought, the documentation of historic iron fencing, original construction techniques. That's how these fences were put together originally when they were set out in the cemetery. In addition to that, participants should also be able to reset fences with few complications. We'll talk a lot about stabilizing corroded iron surfaces, and also applying surface treatments to these surfaces. So before we get started, I just want to start by saying that I'm with the National Center for Preservation Technology and Training. We are a National Park Service research and training facility located in Natchitoches, Louisiana. We have a staff there that addresses issues such as archaeology and collections, architecture and engineering, historic landscapes, and materials research. So if you have any questions, we'll give you our contact information at the end. Feel free to call us, email us, to talk to us about any of the questions that you may have in regards to historic preservation. Now today we want to talk about historic iron fences. And these can be fences in cemeteries, which is a lot of the examples we'll give today. It can be in public parks, around memorial monuments. It can be on buildings, balconies, railings, fences around homes. So all the things that we talk about today apply to fencing in general, historic fencing that could be found at any site, even though most of the examples we'll give today will be in the cemetery, but definitely buildings, parks, anywhere you might find historic fencing. So the first thing we want to talk about is, what is the difference in cast and wrought iron? And these are the two main materials that historic fences are made out of. Cast iron is an iron alloy containing at least 2% carbon. This is heated into a fluid state and poured into a mold. Now when we do that, what we have first is we have our original. This is something that's either carved by a master artisan. A mold is taken from this original. If we'll look at the next slide, we can see sort of our widget shape here. But this could definitely be a fence panel, a finial, a fence post. A pattern is made from this original, and a mold is made by packing green sand around that. And then the parts are cast from this mold. And if we'll look at the next slide, what we see on our right-hand side is actually those molds. So that's a ceramic or iron casing that has what we call green sand in it, that's packed around, was packed around this original shape, and a mold was made from that. And then iron is heated to a fluid state and poured into that. Now this is important. You can get very detailed with cast iron. A lot of times you'll see maybe lambs cast into a fence panel, or willow trees, or maybe even shells, things like that. And these panels are then put together usually with mechanical fasteners. And if we'll look in the pictures here in this slide, we'll see bolts and nuts, also threaded pieces of fencing. That bolts are actually threaded into the fence and tightened that way. And this is important because we'll talk more about the repair of the fence. The mechanical fasteners are important because this is the thing that a lot of times fails, and you want to try to replicate in your conservation work. So we've talked a little bit about cast iron. Next we want to talk about wrought iron. What is wrought iron? Now in the photograph to the left, what we think of traditionally is this. We've got, our skilled craftsmen, our blacksmith drawing and working out ironwork. And this is exactly right. This is how fences were made historically. Eventually machines started doing the work, but the wrought iron process is actually iron that's heated up and then beaten or drawn out into a shape. And what we have are usually very simple shapes. For example, that flower that we saw in the lower photograph. And also in the slide that we'll see next, you had a lot of repetitious shapes. For example, the sort of elongated honeycomb. We have this same stylized shape repeated over and over again, very thin pieces, a lot of geometric shapes. And what we see, the way that wrought iron fences were put together, when we look in this slide here, we have a lot of rivets. And a rivet is a piece of iron that was heated up and then hammered to flatten it out on both sides. And this causes a bond to hold these panels together, these pieces together. In the center lower photograph, we also see what's called a lap joint or a lap band. And this is a thin band of iron that's been heated, wrapped around, and hammered into place, holding two pieces together. The photograph on the far right, what we see is two pieces of iron that are heated and hammered together. And you may be able to see in this photograph sort of that joint around there where these two pieces have been fused together with a hammer joint. So now that we've sort of looked at both of these, let's compare the two between cast and wrought. Cast iron typically is much heavier. You have thicker panels, where wrought iron is much more light and delicate. For example, that elongated honeycomb we saw, very thin pieces. The cast iron can be a lot more detailed. We talked about maybe it has animals or shapes, crosses, shells, things like that cast into it for decoration and detail. The wrought iron tends to be much simpler shapes, like that elongated honeycomb that we saw. We'll look later at examples of thin heart shapes, that sort of thing. Cast iron is typically held together with mechanical fasteners, nuts, bolts, threaded rod, whereas wrought iron is riveted or fused together. Cast iron typically is held together in tension. Now what I mean by this is you have corner post, you have heavy cast panels that are then held together in tension with a top rail and a bottom rail that are bolted together into the corner post. And this is really important. If any of those parts fail, it has a tendency to drop those cast iron panels away when the tension's not there anymore. Wrought iron was more expensive. You had to have a skilled craftsman to do this work. You had to have an artisan to physically hammer out and make these components. So now that we've talked about both wrought and cast, I'm going to sort of throw a wrench into the gear and say that most fences that we look at are probably a mix of the two. For example, the photograph we see on the right, these are very simple, thin, wrought iron pickets and rails that we see, but they're held together with a more decorative cast iron frame. The same with the photograph on the left. We have a sort of heavy, bulky cast iron rail with a big knob finial on it. You have cast iron arrow or spear tip looking finials that are on very thin, delicate wrought iron pickets with sort of a heart detail there. It's important to know which that you have by looking at them and trying to figure out if you have a wrought or a cast iron component. And this is important when we start to talk about some of the repair work that you can do. Repair work that works very well on wrought a lot of times will damage or destroy the cast iron pieces. So it's really important to sort of note the difference between the two of them. A fourth type of fencing that you see historically are drawn wire fences. Now, unfortunately, we don't see a lot of these along the East Coast, and especially in the South. Our weather leads to a lot of corrosion. These fences are very thin. They're actually wrought iron that's been drawn out by machine or possibly even by hand, but usually by machine. And then they're woven together, they're twisted together to make these ornate patterns. These were really popular 1920s, 19 teens, 1920s, and then eventually led way to what we think of more as our wire fences that we see now, the hurricane fences, the chain link fences, that sort of thing. But these are important fences that definitely need conservation work. That photograph's taken in Virginia City, Nevada, where their arid climate allows for those things to survive much longer. Before I move on to talking about the documentation and then further into the conservation, do we have any questions about how to tell the difference between cast and wrought, or any specifics about those two before I move on to the next?
Yes, I have a question. This is Michelle from Midwest.
Yes.
Which is the older technique?
Very good question. Technically, the oldest technique is the wrought iron. The wrought iron was done first. The cast process came along a little later on a large scale. Casting has been done for hundreds and hundreds of years, thousands of years actually. But typically in fencing, what we saw first was the wrought iron. But this was fairly expensive to do. It took a skilled craftsman. Industrial Revolution sort of caught up with us, and cast fences became really popular. Here in the U.S., you see a lot of cast fences start appearing in the 1800s, 1840s, especially up into the 1860s, was a real heyday for the cast iron. Whereas a lot of the earlier fences that are coming around were wrought iron. 1700s, you're more likely to have found wrought iron as opposed to the cast. And then by that time period, we had a lot of sort of large-scale foundries in the U.S. that were making these, especially up in the north, New York, Baltimore, Philadelphia, that region. But typically in the U.S., our wrought iron fences are older. But not always. Wrought iron also continued along with cast iron even up till today. You can still obtain both of them. So hopefully that answered that question. Any more before we move on to documentation? Okay, and there'll be plenty of time for other questions, so be thinking of those. If you want to follow along in page 7 of your participant's guide, we'll talk about documentation. Now, it's important when doing documentation. Some of you may have tuned in earlier to our cemetery monument care TEL course that we did earlier today. And if so, Dr. Striegel talked a lot about cemetery documentation and documentation forms. This is very similar for fencing. It's very important. A lot of times in documentation, people will look at the cemetery monuments or the building associated with it, but they'll sort of skip over the fence and not look at the fence. It's really important to document this. Maybe develop your own fence survey form. There are forms available on the internet, on our website, that you can look at, that you can use, but definitely developing your own. And the kind of things that you want to put in that is, of course, a photograph. They always say a photograph is worth 1,000 words. Also, if we go back to the slide, you can look on the survey form in the lower left-hand corner. We have a very simple map drawn of which of our fence components are still there. This is important if we're looking at possible theft or vandalism in the area. We can know when we did this documentation, did we have a gate? Did we have all the corner posts? Did we have all of the panels? Or have some of these gone missing in this time period? It's also important to identify the cast or wrought, list any manufacturer's labels, and we'll talk about that. Paint colors. This is something people don't think a lot about, paint colors. And here again, any missing features. You want to go ahead and document that they are missing when the documentation is done so that you can tell if you've had any theft or loss due to vandalism. And also, of course, the current condition. And this is also important to do before you started conservation efforts, so you know what the condition was before you started, as well as you can then document the conservation efforts that you took for future generations, so they'll know what was done to this fence and when. So we sort of hit each of those areas. We want to move on and talk about each of them in a little bit of detail. And the first is the manufacturer's labels. A lot of times, especially, but not always, especially with cast iron fences, for example, the photograph that we see in the lower right-hand corner, they actually have the manufacturer's name cast into the fence. And you'll see this sometimes on the back side of panels, also on the bottom of corner posts. Another place is a lot of times with wrought iron fences, small tags were applied. For example, in the left photograph, you have a bronze tag that has the name of the manufacturer. These are important to note. We can tell where they came from. A lot of times through archive research, we can see when the fence was constructed because of the company's catalogs. We can also see what the entire pattern looked like if maybe you only have a few pieces left. And also another thing is a lot of the catalogs historically listed the surface finishes that were available. For example, 19-teens, Vulcan Ironwork Company, they listed almost 20 combinations of surface treatments, and we'll talk about those now. In your documentation, a lot of people think typically of cemetery fencing and fencing around houses, fencing on railings, as being black, painted black, flat black, gloss black, but black. This wasn't necessarily always the case. For example, the National Cemetery gates that we see on the right-hand side not only are painted black, but also had gold leafing on all the details, on the top of the finials, on the shields, on the crest. And this is something that we typically don't do anymore. We just have a tendency to paint over that. So that might be something to look for or to consider when doing any conservation efforts, is what was this fence originally painted with, or did it have decorative elements added to it, such as gold leafing. Also, paint color. It's a good example, especially if you're doing conservation work, to see if there's any paint remnants left over between the rails, underneath the finials, that sort of thing. And we'll look at this next slide here. You want to look for paint or plating remnants. For example, in the upper right-hand slide, we can actually see some of that gold leafing that's still left on, whereas this fence was thought to probably have been just black. The scroll work was all gold-plated. We also see some really nice green remnants of paint in the lower left-hand slide, lower left-hand photograph. So that's something you want to look for, and you want to document that. Photograph it, make note of it, especially before you apply a new coat of paint or a new primer. The only paint that we typically never saw in especially a cemetery setting is red. It's a rather morbid color. We don't typically associate that with particularly memorial, monument, battlefield, or cemetery fences. The only reason I mention that is red oxide primer was typically used, and a lot of times you have that red paint remnants from the primer left over. And a lot of people see that and give me a call or an email and say, well, I think my fence was red. Probably not. It's probably the primer left over. So that's one thing to keep in mind. Also in documentation, this is really important to do before you do any surface treatments, is to note if there's any other metals associated with your fence. For example, the photograph that we see on the left, if this fence was painted, we would not have known that the maidenheads and the finials were actually cast bronze and then applied to very simple wrought iron pickets. And this is important because treatments or chemicals that we would use on iron don't work well with bronze, so we would want to have taken note of that. Also, an important element on the right-hand side is lead. Lead was used a lot with cast iron fences. You see the decorative rosettes here are lead, the urn at the top is lead, and also a lot of times you had lead repairs. If the foundry cast a panel and it had some air pockets in it or some sand from the foundry that cast into it, and they had a large hole, instead of throwing that out, typically they would have filled that void with lead and sculpted it back to match the iron. It's really important to note any of these places, maybe photograph them, draw them on a map, because repair work, especially if it takes any heating of the iron, would damage these lead elements. And once these are all painted, we won't be able to see the difference between the lead and the iron components. So these are really important things to put into our documentation. Now that we've talked a little bit about documentation, about the differences, do we have any more questions, especially about the documentation or about the differences in the two, possibly paint questions, that sort of thing? Okay, hopefully you're thinking some more for the end. Now that we've covered that, I'd like to cover the thing that probably most of you are the most interested in and have tuned in today to listen to, and that's the conservation of these fences and the maintenance and repair of them. The most important thing, and in this order, is the reset and leveling of the fence, the repair and the replacement of fasteners, both broken ones or missing ones, the repair of simple breaks and bends, of course the cleaning of the rust, the removing of this sort of unsightly rust layer that's usually associated with unmaintained fences, treating that rust, cleaning it, and then priming and finally painting the fence. So let's move on and talk about those things. Before we get too far into it, we have to remember the first priority. This is before we start any of the conservation efforts to historic fencing, is you want to think about the adjacent materials. Now these really need to be covered before any work can begin. For example, in the slide we've tarped and we've taped down to protect the grave ledgers that are close by. This is really important if you have a historic walkway along your fence, especially if your fence is mounted to a stone or masonry wall. We really want to cover up that brickwork or that stonework. If you have historic ironwork that is a railing or balcony, it's really important to cover up and tape off any of your historic masonry or woodwork that's directly adjacent to it. The chemical treatments that we're going to be using and even the sanding or wire brushing that we'll do could have serious negative effects. You're spreading rust, paint, things like that have serious negative effects to the adjacent materials. So that's a first priority, the first thing that should be done. Also, fragile plants should be protected. And if we go on to the next slide, keep in mind to cut back vines, to remove stump sprouts. And what a stump sprout is, it's where a tree or a bush has been cut, and you have these green leafy sprouts that have come up from that. You also want to cut or tie back any overhanging branches. So for example, if you have a tree branch that's directly over your fence, it's really going to get in your way when you're doing the work. You might want to pull and tie that back. You may want to cut the thing if it looks like it's going to impact the fence eventually. And also you want to remove small invasive trees and shrubs. Now when I say that, this is a time that you may want to consult a historic landscape architect. You may want to consult a person that's skilled in plants to find out, are the plants that are coming up, are these volunteer plants that have come up naturally, or these things that may have been ornamental that are planted there? If so, these are probably something you want to protect. You might need to tie them back or to cover them up to protect any heirloom plants or plants that have been planted there on purpose. Also, to prevent further damage, a lot of times we have trees that are planted very close to fences. A lot of times the fences were put up to protect these trees, and unfortunately the tree has grown around and into the fence. So we want to look at this and protect the fence as much as possible, but also protect the tree as much as possible. A lot of times these trees are full mature trees and they're very important. If a tree has grown into a fence, the first thing to remember is that they now belong together. We're not going to try to get the fence out of the tree. We'll do damage to the fence, and we'll definitely do irreparable damage to the tree. Unfortunately, probably kill the tree in trying to do that. So what we want to do is we want to cut the outlying fence free of the tree. And then we will make new supports for the fence The reason we want to cut the fence away is what this is going to do. As the tree continues to grow, it's going to continue to push and pull this fence apart. This is eventually going to break your corner post. It's going to break your fence panels. So an example in that lower right-hand photograph, what we could do is cut the fence right, just a few inches away from the tree, and then unbolt this panel away from the post that you see directly to your right and just out of the photograph to the left. Tag these fence panels, put them in storage, and this is going to allow this tree to continue to grow and protect the rest of the fence from being pulled and broken. So once we've addressed these issues, we've covered everything up, we've removed any vegetation or protected any vegetation depending on the case, the next thing that we want to do is then look at resetting and leveling the posts. The posts may be ground supported or they may be set in concrete or stone. They may require excavation to move these posts, and it's very important to keep the posts plumb and level to properly support the fence. Now when we say a lot of them are ground supported, one thing to keep in mind is we're only seeing the top part of the post. The post may extend 2-3 feet further down into the ground. So keep in mind it's probably not a good idea to try to jack up the post because there's a lot of weight, a lot of things supporting that post, and it may break the post. And if we look at this next slide, we'll see some period examples from historic catalogs of what the fence posts look like underground. And in this we have either a bell shape like in the first drawing or in the photograph, and the soil would pack around that to prevent it from moving. So that's a good thing to think about when you're trying to jack up a fence post. So you may want to dig all the way around to release that. And what we see in that left-hand photograph is all of that should be below ground. Unfortunately, in this cemetery, it's eroded away, and the only thing holding this fence up is a couple of small rocks directly under that. So it's really important to put these back properly like they were. So we would need to bring some dirt in or lower this whole fence, more than likely bring some dirt in to try to support that. Your fence posts may also be set in stone. For example, in the next slide, what we see is a simple wrought iron post that's actually set into chunks of limestone. When this project was started, this entire fence was resting on the ground, and it was decided to dig around it to keep the ground contact away from the fence, and in doing so discovered these large stone bases and as well as a brick wall that went all the way around it. So this whole area had to be excavated and raised. Now in posts that are set in stone, these are the posts or the pickets themselves that are set in stone, they're usually set in lead. Occasionally they're set in molten sulfur, and that's when you'll see a bright yellow substance around your fence post. These can be easily reset with molten lead or lead wool, and you can take lead wool, pound that in, and the big thing we're doing here is try to get some adhesion between the two, but mostly we're trying to keep water out. So it's really important to completely fill that hole to keep away any voids. If we look at the next slide, we'll see an example of this. The top right-hand picture, we have a small void right there between the lead and the fence post, and that's actually where water is starting to pool, and it's causing that red staining to leak out of that area and stain the marble that it's set up against. So we should always overfill the hole. This will help shed water away from the iron, and we want to make sure not to leave any voids for that water to sit in. Now also, your fence posts and panels may be set in masonry. So this is really important. If it's set in masonry or concrete, you'll want to get a color match mortar. And if it's historic material, you're going to want a lime mortar. If it's a concrete, you're going to want to try to match that concrete in color and in strength. And you want to overfill that hole and slope it away from the iron. Same thing that we talked about with the lead. That keeps, we don't want any of those voids to trap water, to hold water up against, to corrode our iron. So it's very important to fill that entire void. The next thing we want to look at is what do we do if we have damaged or missing hardware. Now this is really important to try to replace with like size and style. What I mean is if you have a square head bolt and it's missing and all the other bolts are square head, we want to go back with that same style so that it's not unobtrusive. You don't see that, that replacement. We want to try to stick as true to the original as we can. A lot of times iron rivets were used. For example, in the photograph to the right, we have an iron rivet that's rusted, it's corroded, the heads come off, and it's allowing this fence gate handle just to swing freely. We could very easily drill this out and put a new iron rivet back into it. You can still obtain iron rivets. They can be set either hot, or if they're small enough, they can be done cold. We also want to replace the iron bolts if possible. Iron bolts are still available, or if they're not available in your area, we can go with stainless steel bolts for the replacements. Now, to do that, what we want to do a lot of times is drill out the failed fasteners. We also want to re-tap rusted or damaged holes. And if at all possible, you want to stay with that same thread count. Unfortunately, a lot of times when these rust, the hole opens up and expands. So in that case, you would want to go just the next size up. We want to try to keep from drilling any larger hole than we have to. A lot of times you can get thread chasers or thread files to clean up the existing threads, either set into the fence or on any existing bolts. Clean those up and repair that. Next, we want to go on to some of the simple repairs that we can do. And first example, we'll look at wrought iron. A lot of times these finials, pickets, things like that can be bent back into shape. And this can be either done cold if it's not a severe bend, or if it's on a small element. If you have a very corroded element or a very severe bend, you might want to heat it up. You can either use an oxyacetylene flame. Be careful that you're not using a cutting torch that could do damage, but oxyacetylene flame or a propane torch. And this should be significant enough to heat it up to anneal the metal to easily bend it back into shape. Any breaks or tears or rips in the iron can also be welded with a torch or electric welder. So, oxyacetylene torch, arc, TIG, or MIG welding can be done to put pieces back together, which is done fairly easily with wrought iron fences, which isn't always necessarily the case when we're looking at cast iron. Now, with cast iron, the two main repair types are cold repair, this is also called stitching, and hot repair, which is welding. Now, when we're looking at cast iron repair and we talk about cold stitching, and this is a cold repair, so there's no heat involved in this. And if we'll look at the next slide, we'll see some examples of this. And what we're looking at is we've got a broken fence panel that unfortunately has fallen, trees hit it, it's broken half. What we could do, and what we've done in this right-hand photograph, we've actually drilled into both sides of the break. One side we've threaded and we've put in small stainless steel pins of all thread. The other side we've drilled and we're going to put epoxy on to adhere these into place. Now, there are several epoxies available on the market. They can be used for metals. They'll say right there on them, two-part epoxy for use in metal repair. Another thing we want to do is either use that epoxy or a Bondo or metal filling agent to fill any cracks or voids that we may have. And that's going to keep water from pooling and seeping into that and cause corrosion later. So we want to make sure to keep that those voids completely filled, and then of course we're going to prime it and paint it later. Another way that we can do repairs is with heat, and that would be welding. Now, welding should only be done by a specialized professional with the knowledge of cast iron. Cast iron reacts very differently than any other iron type. Actually, the welding can crack and weaken the iron directly around the weld, and this is due to thermal shock. The temperature of the weld actually causes a shock and a cracking directly around it. So we want to be really careful if we do have any of that done. We want to make sure that a trained professional does it who understands the principles and properties of cast iron, who can preheat, do the repair, and then slowly cool the element over time. Now that we've looked at some of the simple repairs, we've replaced some fasteners, we've welded it back together, we've bent broken pieces, we've done our simple repairs. the next step is going to be that surface preparation. And now in the surface preparation, we want to remove loose rust and scale from the surface. And that's all we really want to do. We don't want to get our fence back to a shiny metal surface, and we'll talk about why that is later, because we're in this lecture going to talk about using a rust converter. So we have to have some of that original rust on the surface to let the rust converter work. But what we do want to remove is that scale, that powdery rust that's on there, any large deposits of corrosion, and this can be done with a fine wire. Now the reason we say fine wire as opposed to heavy wire for a couple of reasons. This can be done by hand, like the brushes that we see there in the photograph, or cut brushes or discs on a power tool, but we're talking about very fine wire. This does two things. The fine wire actually lasts longer. It is able to give and move with the brushing, with the treatment, and it actually is going to last much longer than a heavier wire that's going to break off and you're going to lose it and go through lots of them in one repair. Another reason that we don't want to use heavy corded cut brushes or wire brushes is these are actually too strong for the historic fence. And what this has a tendency to do is remove some of the detail, which we don't want, remove too much of the rust, and we'll talk more about why we don't want to do that. But also, it has a tendency to smooth out the surface. And if you think about a pitted, rusted surface, a lot of times you have little pits and little valleys, little peaks between them. These heavy corded wire brushes, like we see in the next slide, will actually bend those valleys over, leaving a little pocket of rust below it that can trap water and also leave rust behind. So in our wire brushing, we want to stay with a very fine wire. Sandblasting is never recommended. Sandblasting actually does a couple things. We can remove too much of the original detail, which we don't want. Sandblasting takes too much of the rust off, leaving a very shiny exposed surface. But also sandblasting can remove what we call mill scale. And mill scale is actually a slightly protective coating that is left on, especially in wrought iron, but also in cast, from the original manufacturing process. It leaves a protective layer on the very exterior of the fence of the metal, and sandblasting can actually remove that, making it more susceptible to rust in the future. We also want to keep in mind that we don't want to grind the metal. We don't want to take a grinder and get back to that shiny metal surface. So now that we've cleaned some of the rust off, once the rust is removed, we want to talk more about some of the surface prep. Once the rust is removed with our wire brush, we then want to wash the surface of the fence. Now I know this sounds kind of odd to wash metalwork, but keep in mind these are exterior fences they get wet all the time. But we want to use a non-ionic detergent or a non-ionic detergent that can be mixed with a solvent. And in doing this, what we're doing is we're removing that biological growth. I'm sure lots of you have seen moss, lichen, and mold growing on historic fences. So in washing it, we're trying to remove that. We're also removing all this loose, powdery rust that we've now stirred up and our wire brushing. So we have to remove that powdery dust, that powdery surface, so that our next treatments can stick to it. So once we've washed the fence, we want to make sure that it thoroughly dries, so that there's no moisture involved, and then we want to put on a rust converter. Now there are two main types of rust converters. There's that are tannic acid based, and those are phosphoric acid based. Now what this does, both of them work the same way. They chemically convert the iron oxide, that's our rust on the surface, into a stable iron tannate or iron phosphate. Now this is a surface treatment that then will be stable, it'll weather the environment better before we move on to our further treatments. The only thing I want to stress is if you live in an area that has high humidity or high condensation, or even that you have the risk or threat of rain over the next couple of days, you don't want to use a rust converter that's phosphoric acid based. If phosphoric acid is not completely cured, it takes about 24 hours, a good 24 hours to cure out our rust conversion treatment. You want to make sure that this is completely dry. If not, it leaves a very powdery, chalky surface that then has to be wire brushed off before it can be primed. Both work very well, tannic or phosphoric, but I do want to stress some caution if using phosphoric acid based. When you're using a rust converter, it's very important to keep in mind your personal protective equipment. And how we know which personal protective equipment to use is from your MSDS sheet. Excuse me. Now, your MSDS sheet is your material safety data sheet. This is available either from the store that you buy or the catalog that you get the rust converter from, but also available from the company who makes the rust converter. And this is either listed on a website, or a lot of times there's a 1-800 number on the label of the packaging. So keep that in mind. On that MSDS, it'll tell you if it's a phosphoric or a tannic acid base, but very importantly, it'll give you the recommendations for personal protective equipment. And this may be gloves, respirators seen here, definitely goggles, that sort of thing. Rust converters all go on white, but they dry a flat black. Now, be cautious, and we talked earlier about making sure we covered up any material around, but rust converters will permanently stain stone, and unfortunately, once these are stained, that's how it is. So make sure that we've covered up any of these materials before we put on the rust converter, and of course before we go on to painting. Now that our rust converter is completely dried, we want to prime the surface. Now I know a lot of people leave the rust converter treatment, that flat black, they leave that and they say that weathers well, and we're going to go with that as a surface treatment. It's going to last much longer if you go that extra step and go ahead and paint primer it. It's going to last twice as long or more than just the rust converted treatment. So you've done this much work, the next steps are very easy, and it'll extend the life of your iron work. In choosing a primer, you want to choose an oil-based primer that is designed specifically for metal, and especially for exterior metals. 1 or 2 coats, it's a personal preference at that point. Once your primer is completely dried, then you want to move on to your final surface treatment. You want to use 1 to 2 coats of an oil-based paint that is specifically designed for metals. If we move on to the next slide, there again, oil-based that's designed for metal and exterior metals at that. Paint colors should match the original or at least be historically accurate. Here again, we talked about when doing our documentation to look around, find out what color our fence was originally painted. We want to go back with that or what it had on it last. Check to see if you want to change the color, if that color happens to be historically accurate to your area, to your park, to your historic site, that sort of thing. Well, now that we've covered documentation, we've covered cleaning, repairs, we've covered surface prep, we'll watch a short video presentation that hopefully will reinforce and show some of the techniques that we've talked about. Be thinking about your questions. When we come back from the video, we want to talk some more, take questions from you. Any questions that you may have, love to hear from. So here's the video. Hello. In this video, we're going to discuss the basic procedures for preserving historic iron fencing. 2 things to keep in mind are to first, do no harm to the artifact itself, and secondly, always exercise personal safety. The first step before beginning any restoration project is documentation. It is important to document the fence as you found it before any work begins. This may be done by filling out a survey form or just writing a narrative description of the fence's condition. It is also a good idea to take lots of before, during, and after pictures of the project. Keep in mind to take pictures of both the details and the overall area. One detail to keep in mind when documenting your fence is to look carefully on the ironwork for any remnants of the original or older paint. On a heavily weathered fence, these may be found underneath the rails or where parts connect. Generally, we think of fences as painted black, but historically a fence could have been painted a variety of colors, such as green, white, or even have a metallic plating. If any remnants of the older paint is left, this should be photographed and included in the documentation. This may also help you decide what color to paint the fence. While we are writing our documentation, let us discuss ways to distinguish between cast and wrought iron. Cast iron is made by heating iron to a fluid state and then pouring it into a mold. It is fabricated in sections that are then bolted together. Cast iron is heavier and cheaper to make. The molds allow for more intricate detail. However, wrought iron is iron drawn and worked slowly with continual heat and pressure. Since it is shaped by forging, this allows for simpler, more delicate pieces and is lighter than cast iron. The pieces are put together with rivets or fused together. The fence that we will be working on in this video is a wrought iron fence that has cast iron corner posts. Now that we have documented the project, the next step is to always cover up any objects in the area where the work will take place. It's particularly important to cover up any stone grave markers, as well as any stone or masonry curbing that may be under the ironwork. Rust, chemicals, and the paint will all cause damage to the stone. Another important thing to check on the fence is that the bottoms of the iron panels are free from the ground. Only the corner posts and support brackets should be in direct contact with the soil. Any unnecessary ground contact will cause the iron to corrode. If the fence panels are in contact with the ground, they may need to be raised, or most likely the soil should be dug out from underneath them. Now that you've been paying particular attention to the fence, you may have noticed loose, disconnected, or broken connections. It is important to fix these so the fence will be properly supported. Tighten all loose bolts first. This may require the additional use of a lubricant. If any bolts are missing, these will need to be replaced at this time. You may want to remove one of the original bolts to match the size and style for the replacement. Iron bolts are the best replacement, but stainless steel may also be used. Occasionally, bolts are broken off or rusted in the brackets. These will need to be carefully drilled out and the holes retapped to its original size if possible. It is important to center punch the hole and use a drill bit smaller than the original hole. Okay, let's get started checking to see if the fence panels and posts are straight and level. If they are not, you may want to lift or lower the corner post. This is only important if the panels are so far out of alignment that they are not fitting together correctly. In some cases, posts may be set in stone or concrete. If the base of the post is too heavy or large to dig around, then it should be left alone. Otherwise, the base of the post will need to be exposed and lifted to the desired height. Gravel or dirt can be placed under the base to stabilize it at the needed level. The next order of your project is to check if any of the wrought iron parts are bent or damaged. If there are any bent elements on your fence, these can be easily straightened with little effort and the right tools. Now that we have addressed all of our structural issues, let's work toward stabilizing the iron. We want to remove only the loose powdery oxidation and any rust scale that is on the surface. Keep in mind that we are going to treat this fence with a rust converter, so some rust must remain. To do this, we're going to use a stainless steel fine wire brush. Heavily corded or twisted wire brushes are too aggressive for historic ironwork and can easily remove too much material. When selecting a wire brush, you want to choose a finer wire. The fine wire lasts longer and is more flexible to reach tough spots and corners. I do not recommend sandblasting, since some of the fence's detail could be lost and the iron will get overcleaned. Once the surface has been wire brushed, you will need to remove all the loose rust and dirt. Washing the surface with a solvent or a non-ionic detergent that can be mixed with a solvent will clean and prepare the surface for painting. This wash will also remove any oil left behind around the bolts. After the surface is completely dried of all moisture, we then treat it with a rust converter. Keep in mind this is a rust converter, not a rust inhibitor or rust dissolver, but a converter. A converter works by chemically changing the iron oxide into a more stable iron tannate or iron phosphate. Most commercially available rust converters are a phosphoric acid or tannic acid base. Some are even a combination of the two. The only word of warning if using a phosphoric acid-based converter is that moisture, including high humidity, cannot come in contact with the surface until the treatment is completely cured. If affected by moisture, the surface will turn a chalky white and must be re-cleaned. Keep in mind that when using any chemical, to follow the manufacturer's recommendations for safety and personal protective equipment. The rust converter must be brushed or sprayed on all surfaces of the iron, paying attention to coat any undersurfaces and crevices. Use extreme caution if spraying the converter, because any contact with stone will cause an irreversible black staining. Once all iron surfaces have been treated with the rust converter, it must have adequate time to cure before you can move forward with the restoration. Check the manufacturer's label for the curing time of the converter that you are using. Once your surface has dried and the converter has had time to properly cure, you can begin priming the fence. You want to choose an oil-based primer that is specifically designed for use with metal. Some primers have rust preventative additives. These are good but not necessary since you have already used a rust converter. 1 or 2 coats may be needed depending on the coverage. You want a nice even coating that is free of any gaps. It is recommended that all primer and paint be applied by a brush to prevent overspraying and staining in the cemetery. Now that your primer has had time to dry, we can begin our top coat. The color that you choose to paint the fence is your own choice that may be affected by the fence's original color or colors commonly used when the fence was originally installed. You may need to consult local ordinances to see if there are any color restrictions in your cemetery. When choosing paint, you want an oil-based paint designed specifically for the use with metal. 2 coats of paint are preferable to get a good, solid surface coating. Now that you've watched this video, hopefully you have all the basics you need to preserve your historic iron fence. One thing to keep in mind if your fence is heavily damaged or corroded is to consult a professional conservator. And always remember to exercise personal safety and to do no harm to the object itself. And good luck. Well, hopefully that video reinforced some of the things we've talked about and also showed some of the techniques that we've discussed. And hopefully you've had a chance to come up with some questions for me. I'd be happy to answer them. So if the audience participants have anything to ask me, I'd like to hear it now.
This is Michelle from the Midwest region. I work with National Historic Landmarks, and so they're not really part of the Park Service, but a lot of these are our NHLs are privately owned, but we work closely with the stewards and provide technical assistance. Can we refer them to you for questions? I'm not sure. Does that have to kind of go through us to you?
No, absolutely. And we'll show a slide in just a minute with my contact information. I am more than happy to help parks, NHLs, the private citizen, the mom and pop who've got a fence around their house that's historic. Email is the best. I travel a lot, so calls sometimes don't get answered for a while. Emails are the best, but I'm happy to help anybody. Your tax dollars at work sort of thing. But I'm very happy to answer any questions that people have. It's important to try to save these pieces of our historic fabric. Other questions? Okay. Well, if there's no further questions, and by all means, like I've said, you can contact me later if you do have questions or specific examples that you want to look at. One thing I'd like to tell you all about is upcoming workshop that NCPTT is hosting and organizing, and I'll be teaching at along as well as other conservators. We're doing an ornamental iron workshop June 18th and 19th in New Orleans. You can go to our website and find out more information and also to register for this workshop. This will be hands-on in the field. We'll do some lecture, more in depth than what we've covered today, but then actually go out in the field and do a lot of these treatments that we've talked about and do physical conservation work to some fences. And that'll actually take place, the hands-on will take place in St. Louis Cemetery number 2, restoring some fence work there. So it's a good opportunity if you have questions or if you've wanted to try some of this, that we can work one-on-one with you or in small groups to show you some of those techniques and some of those hands-on. Also on our website, we'll have this broadcast archived as well as ones that we've done in the past about fencing, ironwork, as well as cemetery monument conservation and other issues. The video that you watched as part of this is also on there, as well as other videos that we have about everything from lime washing to building rock walls to historic landscapes. These are available on our website as free downloads, or you can order DVDs through our product catalog. So make sure to go check that out and get more information from us that way. And also, if there's no other questions at this time, also want to tell you how to get course credit for this, and that is to go to the NPS.gov website, go to the DOI Learn tab, and click on the class evaluations for this class, which is the basics for historic iron fencing care. This needs to be done within 2 weeks to get credit for the class, so make sure you do that so you get your credit. And I'd just like to, one more time, give you my contact information in case you do have questions, in case you do have any other things you'd like to discuss and can't think of it today. But, give you one last chance. If there's any questions out there that you might have, I'm happy to take them while we still have a moment or two. Any last questions? If not, thank you very much for taking your time today to join me. Hope I was able to answer some of the questions that you had, maybe all of them that you had. And feel free to contact me in the future. And I'll sign out today and let you sign back out with the NCTC Eagle Cam here. So thank you very much, and we'll see you soon.